Hi, my name is Michaela, and today I will be doing the 2009 FRQ for AP Calculus AB number 5. So first let's see what this question entails. It has 4 parts and it's a non-calculator question, and the concepts include derivatives, integrals, and Riemann sums. Specifically the fundamental theorem of calculus and the mean value theorem. So let's see what this question is asking. It says, let f be a function that is twice differentiable for all real numbers. The table above gives values of f for selected points in the closed interval 2, x, 13. And 2 is less than or equal to x and less than or equal to 13. So this is a fairly simple problem. We're just using basic calculus concepts and the numbers are pretty easy to work with. The only difficult part is part D. It's probably the most challenging part to this question. So this problem definitely isn't one that we're not familiar with. We've had many questions involving the mean value theorem and Riemann sums. So let's start with part A. Part A says, estimate f prime of 4. Show the work that leads to your answer. So what we're doing here is we have a table of x values and f of x, and they want us to find f prime of 4. So we're given the basic function and we need to find the derivative, and we need to find the derivative of an x value that's not there. So what we're going to use is the mean value theorem. So the mean value theorem says that f prime of c is equal to f of b minus f of a all over b minus a. So this is basically the slope between the 2 points, and that will give us the derivative of the point in between a and b, which is c. So for this problem, this equals to f of 5 minus f of 3 all over 5 minus 3. This works because the x value of 4 is in between 3 and 5, so we can use this here. In the beginning of the question, it also says that the function is twice differentiable, so we know that we can use it to find the first derivative for one of the values. So this equals f of 5 is negative 2 minus f of 3 is 4 all over 5 minus 3 is 2. That equals negative 6 over 2, which is negative 3. And that is the answer for part A. Now let's move on to part B. Part B says, evaluate the integral from 2 to 13 of 3 minus 5 f prime of x dx. Show the work that leads to your answer. So we're going to be using the fundamental theorem of calculus for this problem, as well as just basic knowledge of integrals. So what we're going to do is first let's write what we know. So we have the integral from 2 to 13 of 3 minus 5 f prime of x dx. So the easiest way to do this problem is to split up the integral. So when we split it up, we'll have 2 to 13, integral of 2 to 13 of 3 minus the integral of 5 f prime of x dx. I'll have dx here too. Now we have the integral from 2 to 13 of 3 dx minus the integral from 2 to 13 of 5 f prime of x dx. So now that we're here, we can use the fundamental theorem of calculus. The fundamental theorem of calculus states that from the integral of a to b f of x dx equals the antiderivative of b, f of b, minus capital F of a. So that is the fundamental theorem of calculus. So we are going to use that to complete this problem. So the antiderivative of 3 is 3x, so we are going to say that 3 times 13 minus 3 times 2 minus, we can bring this 5 out to the front, bring it over here, so minus 5 times the antiderivative of f prime of x, which is just f of x, so f of 13 minus f of 2. So here we have 39 minus 6 minus 5 times f of 13 is 6 and f of 2 is 1. So 33 minus 5 times 5 equals 33 minus 25, and that gives you your answer of 18. And I'll just make a side note here that the antiderivative of 3 dx, or the integral of 3 dx, is 3x. That is why you plug in 13 for x here and 2 for x there. And this equals 1 plus 8 minus 6 plus 15, and that will give you your answer of 18. So let's look at part D. Suppose f prime of 5 equals 3 and f double prime of x is less than 0 for all x in the closed interval 5 is less than or equal to x is less than or equal to 8. Use the line tangent to the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. So first I just did the first part, the tangent line. So our slope at 5 is 3 because the derivative f prime of 5 equals 3. So this is our slope for the tangent line. We have our basic line equation here, and let's just plug in what we know. So we have negative 2 from the point 5, negative 2, which was given to us at the beginning, equals 3, which is our slope, times 5, which is our x value, plus b. Solve that and you get b equals negative 17. So you get your tangent line equation, which is here, y equals 3x minus 17. So to verify that indeed f of 7 is less than or equal to 4, let's plug in 7 for our x value and we get y equals 4. So we know that f of 7 is less than or equal to 4 because the second derivative is less than 0. This means that the tangent line is falling away from the curve. So f of 7 is less than or equal to 4. Now let's move on to the secant line part. So the most important thing to remember here is that a secant line goes through 2 points, unlike a tangent line that only hits 1 point on the graph. So since they give us that x is going to be in between 5 and 8, we know that our 2 points that we can use are 5, negative 2, and 8, 3. These points were given to us on the table. And now let's just find the slope between these points. So negative 2 minus 3 over 5 minus 8 equals 5 over 3. Now we're going to go back to our basic equation of a line. We have our slope and we're going to use the point 5, negative 2 again. So let's have negative 2 equals 5 over 3 times 5 plus b. We have negative 2 equals 25 over 3 plus b. And let's just subtract those, so that's this minus 25 over 3 equals b, and b equals negative 31 over 3. So our equation is y equals 5 over 3 x minus 31 over 3.